Starting with letter B. And in letter B, I need to find the measure of angle P. Now, there are three different versions of this theorem that we need to apply, or three different cases, I suppose. And one of the cases is the one we just proved, and the one that we're going to be dealing with here, where I have two tangents. So my angle exterior to the circle, angle P, is actually made up of two tangents, okay? But all of the cases are going to be worked the same way. So what I'm going to have to do is subtract one of the intercepted angles from the other, the smaller one from the bigger one. I'm given this 95-degree intercepted arc right here. Can I infer what the rest of this arc, what the other side of this arc has to be? Well, the whole circle has to be 360 degrees all the way around. So that means that this major arc is going to be 360 minus 95. 360 minus 90 is 270, so minus 95 is 265. And what this is going to be is 265 degrees minus 95 degrees times 1/2 is going to give me the measure of the angle. 1/2 the measure of one intercepted arc minus the other intercepted arc. And this is what this is going to look like for tangents. Okay, 265 minus 95 is going to be 260 minus 90, which is going to be 170. Okay, so this is going to be 1/2 times 170. 1/2 times 170 is 90. Nope, 85. It has to be 85. So we should have a measure here of 85 degrees. Let's just make sure we did this one right. The measure of angle P, 85 degrees. Let's go on to letter C. Okay, letter C uses this same diagram for C and D. Okay, so we're just looking for measure of angle 1, which is this small angle down here. Well, this is the other case, one of the other cases that I could have with these external angles. Notice that one of these lines is a tangent, BE. One of them is a secant. And then lastly, the other case that we're not going to deal with in the practice, but it's the case that's shown in the theorem where I actually have two secants that intersect outside the circle. Here I have a secant and a tangent, but no problem. It's still going to be the same concept. It's going to be 1/2 one of the intercepted arcs, the bigger one, 154, minus the smaller intercepted arc, 88. Let's see, 154 minus 8 brings me down to 146. 146 minus 80 is 66. So it's going to be 1/2 of 66 degrees, if I did my math right, which is 33 degrees. So angle 1 should be 33 degrees. Let's see if we got that right. Yes, there we go. And then on to letter D. In letter D, we have the exact same thing as we did in the previous problem because we have two tangents. It's the big angle, ABE, okay? Measure of angle 2 is actually ABE. So what I need to do here, I have 88 degrees, 154 degrees, 64 degrees, but I don't have this little angle right here. How do I find that? Well, I'm going to have to use a calculator to do 360 minus these other three values. And I'm just going to use a calculator for this because it's a lot to keep in mind to do in my head here. So it's going to be 360 minus 88. Okay, that's one of my angles. Minus 154 minus 64. Minus 154 minus 64. And how many degrees are left over to complete the circle? It is 54 degrees. So that means that this angle here is 54. So that means that my total small angle is 138, 142. So I'm going to put in 1/2. I have an angle minus 142. My bigger angle is 154 plus 64. That's going to be 158 is 218. I believe that's 218. Let me just double check my work here and make sure that these add up to 360. 218 plus 142, 360. So we did it right. All right. So this is going to equal 1/2 times 218 minus 142. Let's see. 218 minus 2 is 216. Minus 40 is 176. Minus another 100 is 76. So I believe this is 1/2 of 76 degrees. Oof, we'll see if that's right. That's pretty close to the previous answer. 1/2 of 76 is 38 degrees. Could it be so close to the previous answer? Let's find out. 38 degrees. Okay, we did it right. And then letter E. Here we're going to be thinking if a flashlight illuminates a 154-degree arc on a spherical object, how many degrees wide is the beam as it leaves the flashlight? So what we're going to do is we're going to imagine that we're shining our flashlight on this sphere here. Let's pretend that this is the flashlight. Point P is the flashlight shining on a sphere, except this angle here is 154 degrees. So that means that to find the angle of the beam of the flashlight, I'm going to take 154. I'm going to 1/2, whatever the other side of the sphere is that I don't know, minus 154 degrees. Okay, now, what's the side of the sphere that I don't know? This is my flashlight, let point P. This is the amount of the sphere that's illuminated. What's the other side? Well, it's going to be 360 minus 154. 360 minus 154 is pretty easy to calculate. It's just 206. 206 minus 154 is 202 minus 150, 52. 1/2 of 52 is 26. So I think my answer is 26 degrees. Let's just see if we did that right. Bam. And that is how you work these sorts of problems. Now you're ready to do the problem set for next time.